Hello friends, welcome again to the tetrahedron chemistry classes. So in the series of the polymer science, today I am going to discuss my second synthetic rubber, and the name of this rubber is the NBR, right? That means your Buna N rubber. The name of this NBR is the Buna N rubber, or you can say the nitrile butadiene rubber, right? Nitrile butadiene rubber. And it is also known as the grade A rubber. As I already told you, this is the American system of nomenclature, right? So we don't need to understand much this nomenclature, but only you need to understand the full form of the NBR, the nitrile butadiene rubber, or the Buna N rubber, where N stands for the nitrile, right? So you can see this is your butadiene, okay? This is 1,3-butadiene, and this is your nitrile, acrylonitrile. Nitrile means cyanide linkage would be there. So this is again again a copolymer, because we are using the two different kinds of the monomers here. And you see this is the structure unit of this particular, we can say the repeating unit of this polymer, and this is the copolymerization, right? And the same thing is happening here. This particular double bond is breaking, and one electron is shifting on the left hand side terminal carbon atom, and another electron is coming between this carbon 2 and 3. And similarly, you can see this double bond which is present between the carbon 3 and the carbon 4. It is undergoing the cleavage. So one electron is coming here on the right hand side carbon terminal carbon atom, and making this carbon as the active species, and another electron is shifting again the carbon 2 and 3. So these two electrons will combine to form a bond. So this would be the new double bond here, and this is the active center. This is another active center. So bifunctionality is produced in this particular molecule. Similarly, here you can see in the acrylonitrile as well, this double bond gets break. One electron gets shifted on this particular carbon. It is the active center, and again this electron is shifted between this on this particular carbon atom, again the two active center. So the bifunctionality achieved in both the cases, okay? And this will attack now onto this particular active center as well as on that particular active center, okay? So again it is 1,4 addition product, right? 1,4 addition product, and you will get this particular polymer, okay? So this is the synthesis or the formation of the NBR rubber. So what will happen in that case? The nitrile rubbers are polymers of the butadiene and acrylonitrile in the ratio of the 75% and the 25% respectively. That means 75% would be your 1,3-butadiene, and only 25% of acrylonitrile would be there. It is again prepared by the process of the emulsion polymerization. That means production will be done by the emulsion polymerization, like we have seen in case of the earlier one, your Buna S rubber, butadiene styrene rubber, okay, using hydroperoxide as initiator, because this is the, again you can see this is the addition reaction, right? 1,4 addition product we are getting, so we need to the initiator. So hydroperoxide would be the initiator in that case, or sometimes you may take the hydrogen peroxide and ferrous sulfate as initiator as well, okay? So this you need to understand. Now the properties of the Buna N rubber, right? That means butadiene nitrile rubber. So due to the presence of the cyano group, right, it is less resistance to the alkalis than the natural rubber. In the natural rubber there are no such cyanide group present, okay, but in that case cyanide group is present, and from the basics of the organic chemistry you all know the cyanide is actually readily attacked by the alkali. So whenever the alkali environment would be there, then the use of this Buna N rubber would not be recommended, okay? Second, it has a good tensile strength and the abrasion resistance. This property is same as of your Buna S rubber. Third, it possesses excellent resistance to heat, sunlight, acids and the salts, okay? So heat, sunlight, acids and salts, this particular Buna N rubber is resistant, very good. It has very good or very excellent resistant nature against these environmental factors, okay? So it can be used it can be used where such impurities are there efficiently, right? Number 4, this rubber are less resilient than the natural rubber, okay, or definitely the resiliency would be less in that case. And again I am telling you what is the resiliency or resilient nature, okay? Resiliency means material's ability to absorb the energy without deforming or without breaking, okay? and number 5, it has a good heat resistance, which I have already mentioned over there. Okay, and if the property if it is properly protected by the antioxidants, it shows the resistance to the oxidative degradation, but you have to do some modifications on this, right? So these are the some of the important properties of the Buna N rubber. And now then there comes the application part, right? Applications of the Buna N rubber. Nitrile butadiene rubber, right, or you can say the butadiene nitride rubber are used for the oil resistance, right, because it is resistant to the oil. It is so where this application required where the oil is there, right, then you can conveniently use this particular rubber, especially in the labs and all there, right. Conveyor belts, you see the conveyor belts are also made by this one. These are the conveyor belts which are used in the various equipments. Okay, then lining of the tanks, right, again lining of the tanks would be the another applications like your Buna S rubber. And again the gaskets, right, so I hope you know what is the gasket. Gasket is the kind of the sealing, right, between the two surfaces, like in the pressure cooker we are having the rubber gasket, right. So these gaskets are made up of the Buna N rubber as well. And similarly you can see the printing rollers. In the printers you find the different kinds of the rollers. So this material is actually from made from this Buna N rubber. And oil resistance foams are also made by this Buna N rubber. And similarly you can see this nitrile rubber is very famous in the labs as well, in chemistry lab, right, and in the pharmacy, everywhere you find this gloves, and these gloves are made up of the Buna N rubber or nitrile rubber, right. So automobile parts and the high altitude aircraft components are also made up of this Buna N rubber, and it is also used as adhesive. So this is a quite short note on this Buna N rubber, which would be very helpful in your examinations as well. So that's it for today, right. If you understood the lecture well, please like the lecture and do share with your friends as well. And if you are watching video for the first time, okay, then please subscribe the Tetrahedron Chemistry classes. I'll meet you with some other rubber or say synthetic rubber in my next class. So that's it for today. Thank you very much.